Effect of catalyst. Catalyst. What is the catalyst definition? A catalyst is a substance which is increase the rate of a chemical reaction without itself undergoing any permanent chemical change. It do not change any chemical change, but it convert the reactant to product very fast. Example, KClO3 converted into KCl plus 3O2. This MnO2 is a manganese dioxide as a catalyst. Another one substance is the inhibitor, the substance which reduces the rate of a chemical reaction. Any one substance which reduces the rate of chemical reaction, that is called inhibitor, which increase the activation energy and reduce the rate of reaction. So how this catalyst is affect the rate of reaction? It is given in the form of mechanism. The action of catalyst can be explained by the intermediate complex theory. Catalyst plus substrate, catalyst denoted with the C, substrate denoted with the S. This will form a intermediate complex with the partial bond. These partial bonds are break down and convert into product and so I wrote here enzyme type, that is actually catalyst. C, that is, you correct it. So this catalyst provide the alternate path. How it increase the rate of reaction mean? It provide the alternate path or reaction mechanism by reducing the activation energy between the reactant and product, hence the lowering potential energy barrier. So totally it reduces the activation energy. For an example, this is the uncatalyzed path. This is the activation energy of uncatalyzed path. Some amount of activation energy. Now this green color path is a catalyzed with the EA green color activation energy. This is a less than the yellow color activation energy, that is uncatalyzed path. So green color is the catalyzed, yellow color is the uncatalyzed. So uncatalyzed activation is greater than the catalyzer. So according to the Arrhenius equation, K equal to e power minus Ea by RT. Ea activation energy increase mean rate constant decreases, then rate of reaction decrease. So activation is lower mean rate of reaction is higher. Then reactant convert into product by a substance that is called inhibitor, which increase the activation energy, that is the red color, higher activation energy. Activation energy increase mean rate of reaction decreases according to the Arrhenius equation also proved. Now the reactants are converted into product. So react energy higher, product energy lower. The difference between the reactant and product is called enthalpy of reaction. So reactant converted to product is exothermic reaction, that is negative value from higher level to lower level energy conversion, exothermic reaction. So total overall meaning what is that? Catalyst decrease the activation energy. Characteristics of catalyst. The first one point is a small amount of the catalyst can catalyze a large amount of reactant. So keep in mind, for any amount of reactant, small amount of catalyst is enough. No need to use a large amount of catalyst. A catalyst does not alter the Gibbs energy of a reaction. It do not change any thermodynamic parameter delta G, delta H. You can observe the graph, in that we'll get these thermodynamic parameter does not change. So catalyst increase the rate of reaction but not change any thermodynamic parameter. Third one, a catalyst catalyze the spontaneous reaction but does not catalyze the non-spontaneous reaction. So already if the reaction started, meaning for that it increase the rate of reaction, but the reaction which is not started, for that did not increase the rate of reaction. Fourth one, the catalyst does not change the equilibrium constant of a reaction, rather it helps in attaining equilibrium faster, because we know Kc for a reaction is fixed, it change with the only temperature or stoichiometric coefficient or when the equation is reversed, but it does not depend on any other parameter. You studied maybe in the first year also, therefore does not change the K value. Kc is equal to what is the forward by K forward by K backward, therefore it does not change the equilibrium constant, but it helps to reach very fast. Catalyst catalyze the forward and as well as the backward reaction with the same extent, so that equilibrium state remain same but it reach earlier. K value K forward by K backward, therefore forward backward reaction rate will be equally increased. Next one. Now, we drawn a graph between the potential energy and reaction coordinate. We have the reactant converted into product with the different energy of the product. One is a blue color graph that is converted into product. Then it's had activation energy EA blue color. So its activation is greater. Second one EA green color, its activation is lower, mean kinetically fast, but the product energy is higher, and blue color product energy is lower, therefore blue color line is thermodynamically stable. Activation energy of green color is lower, that's why kinetically very fast, so that is called kinetic product. Then blue color energy is lower in the product, therefore thermodynamically stable. So reactant current to product in the kinetic and thermodynamic both are gives a negative energy, it means exothermic reaction. Now we'll consider the another graph, in that also potential energy and reaction coordinate. In this reactant convert into product. Here also we have the two curves, one is a pink color, another is a green color. So this pink color convert into product higher energy with the activation energy EA pink color, and next one green color convert into same product with the lower energy with the lower activation energy green color. So now this activation is lower, mean faster reaction and also lower energy. Therefore, thermodynamically and kinetically it is a stable product. Now, keep in mind reactant control product, this is a exothermic because energy loss. Both reaction whatever I given exothermic. Now delta enthalpy of reaction, that is delta H, is EA forward minus EA backward. If it is negative exothermic, if it is positive that is endothermic. So for endothermic we drawn one graph, potential energy plus reaction coordinate. Product higher energy, reactant lower energy, activation energy is EA. So this is delta H is positive, therefore it is called endothermic. So product higher level, reactant lower mean positive endothermic. So based on this they will ask in the competitive exam very important question, reactant converted to product. In this we have converted reactant to product. So first one react lower energy level to product, that is X. Then reactant to reactant converted to product is EA forward activation energy, and that is backward mean EA B, that is called backward. So EA forward is equal to what is that Z. That's why first question answer is Z kilojoule per mole. Then second one, that is EA backward, that is from product to up to maximum, that is Y plus Z. Therefore, Y plus Z kilojoule per mole EA backward, that is. En, meaning what is that? Normal energy, that is. Energy of the normal molecule. That is which one? X plus Y level, that is from bottom to energy of the normal molecule up to reactant. Therefore, we have to consider X plus Y kilojoule per mole. Then next one, threshold energy. ET mean what is called threshold energy. That is from bottom blue color line to up to top. Therefore, this is X plus Y plus Z. This is from bottom to up to maximum level. X plus Y plus Z kilojoule per mole this is. Now, delta H, enthalpy of reaction, that is Y. It is exothermic or endothermic. We will decide with the next equation. I given just Y. Now I will prove that exothermic or endothermic. EA forward minus EA backward formula, we know that. So EA forward value already first one answer, that is the Z minus minus. So next one, EA backward. EA backward value we know, Y plus Z. So plus Z minus Z cancel, and Y is a minus sign, therefore minus Y kilojoule mole inverse. That is called exothermic reaction. Based on this, reactant converted product is a totally exothermic reaction, that is negative value, therefore we call exothermic. Next one more graph drawn here, reactant convert into product. In this, we drawn a graph with the activation energy E1, second one is activation energy EA2. We have the two transition state, that is the transition state 1, transition state 2. Now higher the activation energy mean, that is called slow step, lower the activation energy is called fast step. So EA1 and EA2 are the activation energy. So based on this, we can consider here activation energy 1 is greater than the activation energy 2. So activation energy is 1 greater means slow step, and activation energy lower means that is a fast step. EA1 slow, EA2 with the fast. So in between these two transition state we have the intermediate, that is a blue color indicated. So the number of steps is equal to number of transition state. We have transition state 1 and transition 2, therefore two step mechanism this is. And number of intermediates are equal to number of transition state minus 1. So only one intermediate, because transition states are 2 minus 1. So now faster reaction meaning a lower EA, slow step mean higher EA. So higher EA mean that is a rate determining step. Higher the activation energy is called rate determining step. Lower the activation is called faster the reaction rate. So totally we have to understand from this catalyzer reactant convert to product, exothermic or endothermic, reactant upper energy level and product or lower energy level mean exothermic. In case product up and reactant down mean that is a endothermic reaction. Subscribe and share, like. I hope you understood well. Thank you.